Welcome. I'm busy doing an upgrade to my rotary table. I'm making a spin indexing attachment for it, and I've already done the indexing plates, which was quite a hairy project. Now this project, I'm doing the two arms that you use to select do your hole spacing in between. So that when you do your indexing and you say +3 holes, you set your arms to those 3 holes and you just move the lever over that amount. I don't know what you call these arms. I'll just call them dials. I'm not exactly sure what the technical term for it is. You can drop me a comment so that I can get the correct name for it. And then, this was cast. Now I've cleaned up this aluminium quite a bit. As you can see, the amount of inclusions on it is a lot less than usual. And now I need to machine it. Now if I lay it flat on the table, you can see you can hear the rock. And on this end there's quite a massive bow on it. So now what I want to do is to start off with this face here and clean this up. Now that I'm going to do on my faceplate. Now I found that if I mount it on the faceplate, there's virtually no rock on it. And then what I'm going to do is I've got a couple of thick washers that fits into the holes, but it doesn't pull through because these holes are taper. And then once I bolt it down, this entire face will be open for me to machine. Okay, let's start. Okay, it took 3 passes to get a full cleanup. I've removed around 1 mm from this face, and the surface finish is perfect. I'm very happy with it. Now I'm only running the lathe at 300 RPM, and my video is sped up for the sake of time. And the reason for that is faceplate work is very dangerous. On lathe work, faceplate is probably the most dangerous tool in the kit, because parts can fly off and injure you if you're not taking proper care. So you should apply common sense when you use it. And the lower you run your lathe, the less chance of something coming off causing serious injury. So yeah, I think I'm ready to cut it in half now. And then because of this flat face, I can now go back to my 3-jaw and do the rest of the features, because I need to focus on these bores here. Okay, I need to bore out the center here. Now my chuck is going to be in the way if I clamp it down flat, so I need to offset a little. So I'm going to put in a spacer. As you can see, I've knocked out the spacer, and the surface should still run through to the face of the chuck. So now I can bore out without hitting my chuck. I'm going to take this hole up to 38 millimeters, a little bit oversized, maybe 38.1, because I need it to be a slip fit around the shaft of the rotary table, and I don't want it to bind. Now the other part will be bigger because these two parts needs to spin coaxially to one another and inside one another. As the video progresses, it will make sense. Now, if you're wondering why I haven't clamped this thing outside so that I can clean up this face as well, it's because this whole feature here is taper, so it's just running on the edge here. So it's good enough to get the bore done. Once the bore is done, I can close the jaws, clamp it on the inside, and then do the outside feature. And because I've only got it clamped on this outside edge here, I'm not going to take very deep cuts, even though it's aluminium. Can use kerosene again. I think that's good enough. Yeah, the first one is done. The lathe work in it, I still need to do some milling on a rotary table. Now I've got it to a thickness of 12.95 millimeters, and now I have to do this one. Bring it up to the same point. Only difference is this hole is now going to be 45 millimeters, whereas this one is 38. Now 45 is half the thickness of this wall here, because I still need to mold down this inside the radius here, or outside the radius for the OD of this particular hole, but it's going to run through this section here, where this piece here is going to seat inside there. Okay, there's a little bit of an inclusion here, but it doesn't matter because this arm is longer than it needs to be. And I've had a quick look. These things are called sector arms. So if you agree with that, you can leave a comment. If you don't agree, you can also leave a comment. That's the information that I managed to find. A friend of mine went through his manual of his rotary indexer or indexing aid, and it's called something completely different, which doesn't make sense. But anyway, we'll go with sector arms and see. Right, what I need to do now is cutting around 5 millimeters away from this face here, up to this point here. Now this is going to assist the two halves to sit inside one another, almost like a set of pliers where one set is cut to fit into the other part. So it's a similar principle that applies here. I think that should cover this section here. And 5 millimeters is more than adequate. If you go any deeper, then I risk cutting into my jaws here. In order to do the other features. I need to do it on a rotary table, but I need a mandrel to mount it to the rotary table. I also won't be able to locate it successfully. So now I'm just going to make a quick mandrel. It's going to be two-sided for the two different sizes of holes. Okay, the last bit of machining I didn't film because the video is going to get too long-winded. Now let me explain how this is going to work. Now on both of the sides I've got a 21mm boss. That is going to sit in the center of my rotary table pallet. I've got the sacrificial pallet table with a 21mm boss in the middle. So whether you turn it like this or this, the boss will always be locating on both ends. And then on the one side, it's got a matching boss for the 45mm sector arm. And if I turn it around, it's got a boss for the 38mm sector arm. So yeah, it's quick and simple, universal, just swap it around and you don't need to lose your location on your rotary table. I'm going to end this video here because it's getting long already. So the milling work I'm going to do in the next video, and then you'll see this in action. Until next time, cheers.